All right, let's talk black holes. What's the first thing that pops into your head? If you're like most people, it's probably those giant space monsters from the movies, right? Cosmic beasts just devouring everything in their path. But the real story? Oh, it is so much cooler and honestly, way, way stranger. So today, we're going to peel back all that sci-fi myth and get to the incredible science underneath. And let's just start with the most terrifying idea first, shall we? A rogue black hole. Think of it like a star's ghost, not tied to any galaxy, just drifting through the cosmos. If one of these wandered into our solar system, we wouldn't even see it coming. We'd just feel it. Planets would start getting yanked from their orbits, and by the time we figured out why, it'd be game over.
So this brings us to the big one, right? The question that maybe keeps you up at night, staring at the ceiling. Could a black hole actually swallow the Earth? Is this a fate we need to be worried about? Let's dig into the physics and find out.
Okay, first things first. We have to tackle the single biggest misconception out there, that whole idea of black holes being giant cosmic vacuum cleaners just sucking up the universe. Yeah, that image is just plain wrong. A black hole's gravity is seriously powerful, for sure, but it has to play by the same rules of physics as everything else. It doesn't just magically hoover things up. The only time you're in real trouble is when you get incredibly close to its event horizon. That's the point of no return. Here's a great way to think about it. Imagine we could just snap our fingers and replace our sun with a black hole that has the exact same mass. What do you think would happen to Earth? We'd get sucked in, right? Nope. Absolutely nothing would change about our orbit. We just keep spinning around it like always. I mean, sure, it would get freezing cold and pitch black, but our orbit would be fine. That's because gravity only cares about two things: mass and distance. It couldn't care less what the object actually is. So if they're not cosmic vacuum cleaners, what are they? Well, astronomers know for sure that they come in two main flavors. And believe me, the difference in their scale is just mind-blowing. This chart is basically a family portrait of the stellar graveyard. Way down at the bottom, you have neutron stars, these super dense cores left over after a star explodes. Then you get the stellar mass black holes, and then way, way up at the top, you have the absolute monsters. These things are so massive that when two of them collide, they literally shake the fabric of space-time, sending out ripples we can actually detect here on Earth. So let's break that down. You've got your small fry stellar mass black holes. They're what's left when a single giant star collapses. We're talking maybe 10, 20 times the mass of our sun. But supermassive black holes? Whoa. These are the kings of the cosmos. They are millions, sometimes billions of times more massive than our sun, and they hang out right in the middle of most big galaxies, including our own Milky Way. And now, things are gonna get weird. Because the real danger isn't getting sucked in, it's getting torn apart. And this whole thing reveals a bizarre paradox about how you might kind of survive falling into one. Physicists have the absolute best name for this process, and it's as horrifying as it sounds: spaghettification. It happens because of tidal forces. Imagine you're falling in feet first. The gravity pulling on your feet is so much stronger than the gravity pulling on your head that your body just gets stretched and stretched and stretched into a long, thin noodle. But here's the paradox, and it's a wild one. That stretching force, the thing that turns you into spaghetti, it actually gets weaker the bigger the black hole is. How does that make any sense? Well, a supermassive black hole is so enormous that its edge, the event horizon, is really far away from its center. So the difference in gravity between your head and your feet is actually pretty small as you cross that line. The stretching is way more gentle. So this leads to a very strange choice of fate. If you fall toward a small stellar mass black hole, you'd be stretched into a noodle thousands of miles before you even got close to the edge. But a supermassive one? You could glide right across its event horizon totally unharmed. You wouldn't feel a thing as you cross that point of no return. Of course, the spaghettification is still coming for you. It just happens much, much later, deep inside. Okay, but this brings up a huge question. How do you find something that's literally invisible? Especially one of those lonely, wandering ones that don't have a star nearby to light them up. Well, for a long time, the only way was to look at how they affect things we can see. You know, like a star that's wobbling because an invisible partner is tugging on it, or the insane speeds of stars at a galaxy's core. But to find a solo black hole, for that, scientists had to get really creative and use a trick that Einstein himself predicted. The technique is called astrometric microlensing. It's a mouthful, I know, but the idea is pretty cool. As a rogue black hole passes in front of a distant star, its intense gravity acts like a lens and literally bends the starlight around it. So from our perspective here on Earth, it looks like that background star's position is wobbling in a tiny circle over time. And by measuring that incredibly tiny wobble with unbelievable precision, astronomers did it. They actually found one, a lone, isolated rogue black hole. And they were even able to calculate its mass, 7.1 times the mass of our sun. And get this, the Hubble Space Telescope had to stare at a single patch of sky for 6 years just to painstakingly track that little wobble. Let that sink in for a second. That's how they found an invisible object smaller than a city from 5,000 light years away. It is an absolutely mind-boggling achievement. So, we've gone from cosmic monsters all the way to real hard science. But let's end this by pushing into something that's still pure mind-bending theory. What if we think about the absolute smallest black holes you can imagine? These are called primordial black holes. They're purely hypothetical, but the idea is that they could have formed in the chaotic first moments of the Big Bang. We're talking about cramming the mass of an entire mountain into a space smaller than an atom. If they exist, they'd be ancient, tiny, and they could be all around us right now without us ever knowing. And that leads to one final, provocative thought. According to some theories, these microscopic black holes could pass straight through solid objects, leaving behind microscopic tunnels. It's incredibly unlikely, of course, but it makes you wonder about the invisible universe that might just be passing right through you at this very moment.